Hi student. Student, today we are going to study about the rocket propulsion. Rocket propulsion means launching the rocket towards its target like the planet or the space station, etc. Today we will understand the basics of the rocket propulsion, and the basics are that principle. What is the principle? Principle is the third law of motion. Third law of motion is very simple. Consider this is the rocket. The fuel will burn, so gases will come out and rocket will move forward. Okay, as the third law of motion is the every action in nature has its equal and opposite reaction. Okay, so this is the principle. What is the principle of every action has its equal and opposite reaction? For example, if rocket will, as the gases will come out in downward direction, so rocket will move in upward direction, that is accelerated in upward direction. This is the principle of this. And construction is very simple. There are so many gas chambers, there are so many fuel chambers in which the solid gases are filled, like the solid oxygen, solid hydrogen, etc. As they burns up, so gases exerts speedily downward, so it's moved in the upward direction due to the thrust produced by these gases. Okay, and as the gas chambers, as the fuel chambers become the empty, so they are left in the space, and important parts, important equipments or devices or the satellite, etc., are adjusted at the top. Launching objects are here, which are to carry towards the target. Okay. Now we will understand working and expressions. There are the two stages: initial stage and the final stage. At the initial stage, we can consider its initial mass is the small m, which includes the gases also, which are to be exerted. And at time t1 t, its velocity, initial velocity is the v. Okay. And at final, after dt time span is its final, its velocity becomes the v plus dv. Okay. After a dt time, its velocity changes v to v plus dv. And mass of the gas is ejected equals to the E. Okay, and velocity of gas with respect to rocket के रेस्पेक्ट में, जो उसमें ट्रैवलर बैठा हुआ है, कॉस्मोनॉट्स बैठा हुआ है या एस्ट्रोनॉट्स बैठा हुआ है, उसको ये स्पीड u लगता है. ओके, सो बाय द सेकंड लॉ ऑफ मोशन. अब सेकंड लॉ ऑफ मोशन से हम ये पता लगाएंगे कि जो रॉकेट है उस पर कितना फोर्स अप्लाई हो रहा है. व्हाट इज द फोर्स which is applied on the rockets? So F equals to dp over dt. So there are the two kinds of the change in the linear momentum. One for the gases, because velocity of the gas is u, which is opposite to the rocket, so it can be written as d over dt of minus m dt. Minus why? Due to the opposite direction. And here u is the constant and m is the variable. Mass तो continuously change हो रहा है gases का field का, so dm over dt. This is for the f, but f equals to m into v, and m is dv over dt. dt will cancel. dv equals to u dm over m. This is the differential equation which expresses the movement of the rocket in space. By the help of this, by solving this, we can find out its final velocity. How will we solve it? For solving this, taking integration both sides का हम जो इंटीग्रेशन लेंगे, dv equals to minus v dm of velocity changes from initial to final. Mass changes from initial to final. Its derivative is v, limit vi to df. Its derivative, log of v. mi to mf, solving vf minus vi equals to log mf minus mi, log mi. So vf minus vi equals to, माइनस से मल्टीप्लाई कर दो, log of mi minus log of ma. According to the logarithms formula, this converts into log of mi upon ma. So final velocity becomes vi plus u log of mi upon ma. If vi equals to 0, so final velocity, ऐसे इनिशियल स्टेज से स्टार्ट करते हैं, और ये इसके लिए इसका सॉल्यूशन आ गया. मास इसमें फाइनल मास में इनिशियल मास का फाइनल वेलोसिटी से क्या रिलेशन होता है. ओके स्टूडेंट, सो ट्राई टू अंडरस्टैंड दिस. थैंक यू.